Well, hello everyone. Thank you so much for being here. I hope this time slot works for you. We try to schedule our webinars around the workday in the UK and Europe where most of our users are. But when looking at the list of registrants for today's webinar, I realized that some of you are in unfortunate time zones. So I really appreciate you taking time out of your evening to be with us today. Welcome to Geolitix, the second generation. My name is Jan Franke. Now, this is, I guess we've done 4 webinars about a year ago when we first launched Geolitix, and those are uploaded to YouTube. So I really recommend that you take the time to go through those because it describes the Geolitix platform and the power of cloud computing for GPR data sets. And it goes through everything from uploading data, importing as a drag and drop interface, to positioning and all the positioning options, to processing and interpreting, and then the different types of output from the platform that are possible. So do take the time to look at those previous webinars. Today what I want to do is talk to you about the improvements we've made over the last 6 to 8 months. Now, Geolitix has been out for, I guess, just over a year, but just because it's a year old, I mean, it's based off 30 years of experience around the globe. We really knew what we wanted to build into Geolitix, but what has been incredibly helpful is the feedback from our users over the last year, users just like you, that have given us ideas, given us suggestions, and explained to us their workflows. But not only the users, all of the manufacturers have been very supportive of this platform and have helped us immensely, so thank you to them as well. What does it mean to have a streamlined workflow within software? Well, see, streamlined workflow might mean something totally different to a utilities company that just wants to go and map a sewer pipe and tell their engineer if it's 6 feet or 6.5 feet, right? That's all they need to know. That streamlined workflow might be very different than an archaeologist who might need to grid a very complicated and dense data set down to 5 centimeters cell size over a vast field to find strange shapes buried in the ground, and they have a different workflow. Or the geologist or the mining engineer who wants to map a very subtle horizon. So the term streamlined workflow is a little bit of a misnomer because it means something different to every user. And the worst use of that word is from the manufacturer because it means streamlined to what they think you should do. And we want to really stay away from that. We want something that is very simple to use, that does not take a lot of experience or training, or certainly not a PhD in geophysics, to understand how to use, but has the functionality of and demands that PhD guy needs from a software platform, but can also be used by the utility company to just tell that it's 6.5 feet to the sewer pipe. And that's a challenge to integrate all of that power, but simplicity as well. And I think what we've done over the last 6 months, you really like it. So what I want to do today is share with you a project. Now, this is a project we've worked on before. It was donated to our demonstration data set from our good friends at Concrete GPR in Portland, Oregon. And it's not going to look like your data set. Now, this happens to be a site that is ideal for GPR, the hyperbolas and the targets. It's a pipe detection, utility detection survey. The targets are very, very clear. The lines were collected with utmost precision. It is a perfect data set. In general, your data set's not going to look like this. Your site is probably not nice and sand and gravels. It's probably got some clays in it. It's very hard to see some of the hyperbolas. They're going to, in subsequent profiles, if you're doing a grid, they're going to come and go, and you have to make decisions on, is this the same utility that we're tracking? And what we've built in to the new features in Geolitix will help you with those more difficult data sets as well. So Geolitix is a simple drag and drop interface. It's very straightforward. And in this case, we're using GSSI data. Now, we've created 2 folders here, one for data in the X direction, one for data in the Y direction. My X direction, let me go and switch screens here. My X direction has files already there, which I've uploaded to save time. My Y direction is empty. Now, to save time, I'm just going to upload one GSSI file, and you'll notice that I am going to grab both the DZT as well as the DZA files. So when you're uploading files, the general rule of thumb is grab the entire directory, take the whole thing and dump it in Geolitix. Geolitix will interpret it and figure out which files it doesn't need and then bring in the files it does need. And we read everything. We're entirely agnostic. We cover every known GPR manufacturer, from obviously the majors down to smaller Russian manufacturers, custom systems from universities. We have implemented everything. So if there's something that you have or that you're developing and you're a researcher that you would like implemented into our import functionality, reach out to us, tell us the format, and we'll have that built in right away. So this is an entirely agnostic system. I've now uploaded my file, gave us a check mark, I accepted it. Let's go and take a look at where these files are. Now, I've already set up this grid. It's a very simple grid. The color scheme is green for start, red for end of each line. So we have all of our 90 or whatever profiles in the X direction. Right now, I only have the one Y file just to save time and just for the purpose of this demonstration. Now, this is a fairly straightforward grid, but Geolitix has the ability to bring in any type of grid you can imagine, be it multiple grids on the same project, or zigzags, or grids that have missing lines, or some of the lines are too long and need to be trimmed. The number of possibilities are essentially endless. We also directly read in predefined grid projects from Sensors and Software in their GPZ files, or Mala Object Mapper, or the IDS grids are all read in exactly the way they were set up in the field. So it's a tremendous time-saving way of just bringing your data in directly. And that's not to speak of all the GPS functionalities. And when you incorporate GPS, I mean, it's obviously a faster way of doing things than a traditional grid, but it opens up a can of worms when it comes to filtering out bad points or dealing with latency, which people tend to ignore for some reason. That's time latency. There's also the offsets between the GPS antenna and the center point of your data set. And remember, Geolitix is absolutely, again, it's agnostic, so it does single channel data as well as multi-channel. It takes in all the multi-channel data from the 3D radars, the MIRAs, the impulse radars, and the stream Cs and stream ups and all of that all come into Geolitix. And there's no different modules, it's all the same cost, subscription cost. So here we are. Let's go and take a look at some of the profile here. I guess we'll start here. Now, this is GSSI data, and we see nothing. Well, that's normal. GSSI data has a very wide bit depth, and this data set is using points that are centered near the middle amplitude, so we don't see a lot right now. Our grayscale goes the full gamut of the bit depth. So all we do is we apply a constant scale. There's a couple different ways of doing it. You can normalize it, but a constant scale will do it, and we have a little warning box that you saw, so we go and click that. And here's our data back. Great. Now we've got to start off with a time zero correction. So this is data that was received, or at least recorded in the receiver, before the transmitter actually fired and before that first arrival got to the receiver. We don't want that, so we'll go ahead and shift everything up. Time manipulation, time zero correction, done. And each of these functions, there's a default setting, but there's a number of different fine-tuning you can do. Either do the entire data set, or if you have shifts or some drifting going on in your data, you can do that on a trace-by-trace basis. But for now, this is all we need to do. Our next step is, I need to gain this up. I can't see much. Now, there's a whole list of gain functions. That's a chapter of a textbook into itself. What I like to use generally is the energy decay gain. It's very similar to a spherical exponential correction, an SEC gain. The nice thing about it is that it maintains relative amplitudes, whereas an AGC gain does not. So when you apply an AGC gain, you might think you're seeing more, but you're losing a lot of interpretation information. So today, let's just stick with the energy decay. Now, what I want to do here is, first thing we have to do is deal with our ringing. So certainly common to all GPR systems, particularly shielded systems, there's a ringing effect, which is the energy just reverberating usually within the antenna housing itself. Easy to remove. There's a couple different ways we can do that. A complicated way, which would be in a 2D FFT, but a much more straightforward way is just a background subtraction. Done. Great. So now we have our hyperbola. I can see my targets quite easily. Let's go ahead and figure out what kind of velocities we're dealing with here. To do that, we go to our interpretation. We select this little tool, and we zoom in. I'm just using my mouse scroll wheel to try and get a better picture of this. And let me see if I can, something like that, kind of good enough. Let's go ahead and assign that velocity. Great. So now we have our project velocity. And if I wanted to, I can just start interpreting it. So let's say I'm interested in this pipe right here. I'll go here and say my pipe or pipe 01. Okay, now what type of interpretation is that? It's a point interpretation. Confirm. We'll leave it as white, and I'll go ahead and draw an interpretation there. Okay, and if I want to go to the next profile, well, there it is again. Click. All right. Pretty straightforward. Whoops, it disappeared there on 4, 5. Does it come back on 6? No. All right, so I happened to pick one that kind of disappeared on me. Oh, and it disappeared on the first one too. So that's probably not a very good pipe to be looking for, but you get the idea. And if we don't like where we placed it, we can sort of correct it right there. Okay, so that's one way of doing things, but of course, this is a very dense data set, so we can look at slicing. But I don't really want to slice and just deal with the slicing parameters. I want to be able to look at this data set, but also slices at the same time. Because when we're interpreting GPR, it's about context. So it's very rare these days that somebody's only doing a GPR survey. Maybe the utility detection company just does GPR, but so much of it is about integrating other data sets that you've collected on site, be it site observations, photographs, a drone. You might have a drone taking photogrammetry. You might have a LiDAR. You might have other geophysical methods, EM conductivity. Perhaps you're looking at magnetics or even an electromagnetic locator. All of that provides context which inform your decision making within your GPR processing and eventually your interpretation. So context is really important, and just going along and clicking on hyperbolas is only part of the story. Slices are only part of the story. And in fact, on that topic, you know, there's a lot of push in the industry to do processing in the field, because there's been a shift in GPR practice worldwide, perhaps not as much in the United States, away from what used to be just spray painting on the ground. So you go out there with your little single channel radar push cart and you spray paint on the ground. Here's my utility. You might give a depth to it, and off you go and on to the next project. And in many jurisdictions, that's not the legal way of doing it, particularly in places like the UK, which is leading the world with its PAS 128. It needs to be documented. It needs to be documented to a specific level of accuracy and confidence. And some states in the United States are like that, as well as Australia. So we're seeing a shift away from just spray painting on the ground to actually capturing data in a proper way, in a systematic way, and going back to the office and processing it and delivering, you know, AutoCAD files or deliverables beyond just a can of spray paint. So, yep, doing things in the field, and you can do that with Geolitix. We have a lot of users that upload data directly from their survey vehicle in the field and are watching and doing their initial processing directly from the field. That's certainly quite possible. But this is all about what we do back in the office and providing context. So on that note, let's take a look at what we can do with our new functionality. Now, it's important to remember that existing users, we haven't changed anything. So this is our new tab. It's called the World tab. Some of our beta testers have already been playing with us for 6 months and giving us feedback. But if you're not a beta tester, then and you like the way the things were, we have all functionality still there. It's in our asset tab, if you remember, it was profiles, asset, output. That's still there. But now the new way of doing things is our world tab, and we really think you're going to love this. So we're looking at this world tab right now. We're looking at a top-down view. If we choose to, we can look at a three-dimensional view, which we'll get to, and that's fully immersive. We can change where our maximum depth is. We can exaggerate things, whatever we want. Let's just go to no exaggeration, or a little bit of exaggeration there. We'll go back to our top view. So now we can see where all our profiles are. These are these 90-odd X profiles and the one Y profile that you saw me upload. Let's go ahead and we have our pipes, the one pipe that I was interpreting there, that's loaded there. In fact, we don't really need that anymore, so I'll go ahead and delete that. So I've got my profiles here. Let's go ahead and go back to my profiles because I want to do some slicing, but I don't want to slice this data set. Now, if you recall from previous webinars, Geolitix has the built-in functionality to have multiple colleagues working on the same data set, for example, but also multiple processing schemes and recipes, if you will. So this is one recipe we've created that worked very easily. It was done in a couple minutes. The data set's all processed, and we can see our hyperbolas. We can go ahead and interpret them. But what if I want to do slicing, but I don't want to destroy their hyperbolas? Well, what I'd do is I would maintain this. I don't want to start again because I don't have time, so I'm just going to duplicate what I have. I'm going to rename this one to slicing. Okay. And here's our data. I'm going to add, let's say here, a migration routine. That's the first thing I want to do. Now, the nice thing about Geolitix is we just have a slider here, and we can move the slider until we get a point, right? So the idea of migration, I'm sure, I hope most of you know, is to take that hyperbola and migrate it and focus it, I should say, into a single energy point source, ideally. So let's keep going a little bit here, maybe a bit more, something like that. So that gives us a nice little point source. It still has polarity to it. So we want to get rid of that polarity, the negative, positive, negative part, and we do that with a Hilbert transform. So now my pipe, or my hyperbola, looks like a blob. There's another blob here, which is probably another pipe. So I've got my slice data set. I'm ready to slice that, but if I go back, I can go back and look at my original data set. I have both of them there. So back to my World tab, I am going to add some slices. So firstly, we want to ask about color scheme. Well, rainbow's good. I think rainbow's pretty. And in fact, grayscale is probably the easiest to see most things, but we'll go with a rainbow color scheme. Now, we want to use the full color spectrum because we've done a Hilbert transform, so the numbers go from 0 up to whatever, 32 bits, and we want to use that full spectrum. So that leaves 0 as blue and a high amplitude as red. Now, which type of processing do we want to use? Obviously the slicing one, because we're doing our slicing. What type of gridding? There's 3 different types of gridding here. It doesn't have a massive effect on things. For now, we'll just use inverse distance. Bidirectional. We don't want to do bidirectional. Bidirectional is very, very useful if you're doing a rebar or surveys where you know that there are orthogonal pipes, for example. So pipes going up and down and left and right. Here I do know what the pipes look like, but they're in every direction, so doing a bidirectional is not going to help us. Our cell size now, apologies, this original survey was done all in imperial. I am Canadian and thus can only think in metric, so I'm leaving mine as in meters, but you can do other units for the Americans and I guess Brits sometimes, who are still in archaic measurement forms. And I will go down to 1.5 meters. There's probably no point going deeper than that. Our slice thickness, that's of course our sandwich. So instead of taking a single slice, I'm going to kind of give us a sum over 10 centimeters. And that should be it. Let's go ahead and process this now. So, and here's where the power of cloud computing really comes into its own. This data set, I think just the X direction is like 350 or 400 megs. It's a massive, massive data set, right? It's almost half a gig. And, you know, had this been a single, whatever my laptop is, 6 or 8 cores, it would have taken a while to go through. Okay, it's done. Go through and process it all. And, well, you just saw how fast it happened. Anyway, so now I can slice through and, okay, well, again, your data is not going to look like this. This is a beautiful data set that's collected in probably sands and gravels and beautiful metal pipes. You know, I've very rarely seen data this clear. So we're kind of cheating here and using a very clear data set, but it's to demonstrate the point. So we have all our slices here, but let's go back into our 3D environment. Okay, so if I, let's see here, we have our vertical exaggeration. Okay, so I want to take my slices and I can slice up and down. Here's our surface, and we've created a little swimming pool for ourselves, but there's more to this than that. So let's take the slices away for a sec and go back to our, in fact, I can turn them off. Now the nice thing here is this is essentially our world tab is going to be the central kind of repository or bucket, or think of it almost as a GIS screen. We not just have our GPR data set in here, but we can add anything we want. Let's add a satellite image and let's select a map box and kind of get some context to this. Okay, so we're in a parking lot and there's a building here. Well, you know what else we can do? Let's say that this was a contaminated site and we did an EM conductivity measurement. So we can add a background image, and let's go ahead and upload a background image, EM conductivity. It'll accept Geotiff files, so if you've got a georeference file already, go ahead and click it. It'll read the boundaries and place your conductivity. Now we can't see it because I've got that on top, so I can move it to the top there. I can take away my slices, and I can move the, let's see, I'll put it on the top. There we go. Okay, so there, sorry. So there we go. We can take a look at our conductivity. We can put our slices back in. We can perhaps have a drone photograph with much higher resolution imagery. I can place that as well on there. So it's a central data bucket, I suppose, for all of your project data. Okay, so I'll put this back into my, I call it my swimming pool. I'll take my slices away. So here we go. In fact, let me take the satellite image away. It might be a little easier, and I will put this on top because I want to show you this. So let's go back and take a look at one of these profiles. I just click on it. Here's my profile. And, well, here's a hyperbola right there. I'm interested in doing some very quick and fast interpretation. So we're going to call this point interpretation. Let's call it, I don't know, my new pipe. Okay. Oh, I feel like a triangle today and a yellow. Sure. Okay. So let's go ahead and edit points. I can click right on there. Okay. Now I want to go to the next one. You can do that manually by clicking down here underneath, but we have this button here, and it just goes to the next profile. Of course, I picked one that wasn't actually there. So let me take that and I don't know. I'll move it to this one right at the edge here, and I'll recenter my view there. Okay, let's try this one. So I'll go to the next one. Oops. Yep, there it is again. And as you can see, the last one turned to a small, and here I go clicking. I'm not doing a very good job of being exact here, but you get the idea. Okay, so here are my points, right? And I could do that for, you know, I can create a new pipe and a different color for this one and do one for each one. It's a very, very fast way of quickly connecting dots. And speaking of connecting dots, we can now take that and create a polyline, an actual pipe. Call that a polyline. And this is, I don't know, gas pipe, whatever. And a gas pipe, I guess we were going with yellow. And we'll give it, well, actually, no, we'll start with this, and I will go ahead and start connecting the dots. Now what I've done here is I've created my gas pipe, but you can see it's a thin gas pipe. It's not really thin. It should be a cylinder, right? And that gas pipe is, I don't know, 10 centimeters in diameter. I have no idea what they're supposed to be. All right, so here's my gas pipe. I can see it now. That's great, but let's look at this. There's a couple ways we can look at it. If you notice, the actual original triangles are sitting on top of the pipe, which is where they should be, because we're picking the apex of the hyperbola. And that apex is exactly where, well, it's the top of the pipe. But we can show that in a different place if we wanted to. We can go back to the center view and place this inside. So in other words, the center of the pipe is at the top of the hyperbola. But the more accurate way of doing it would be below the hyperbola, for example. So there we have, we've created a pipe. That's one way of doing things. But while we're in this view, I want to show you something else. Let me pull up this crossing, this one file that I uploaded, and let me show you what we can do with that. Now, let's say we weren't looking for pipes. Let's say this was, I don't know, mapping the thickness of asphalt. It's a horizon sort of definition thing. So well, let's go ahead and do that. So what I can do is add horizon interpretation, and modify name, and I don't know, thickness of pavement. I'm making this up. It's probably not the thickness of pavement. Pavement is teal today. Okay, so this is the neat part. I can't really see it, so I'm just going to make it up. See how I'm drawing on that new profile I just brought up? But as I hit the corner, get this, I can now turn and go along that profile. Why is that important? Well, and of course I could have gone on this side or just turned the perpendicular profile off and I could continue along. But why is that important? Because when you're doing a geological horizon mapping exercise, you really want to have those intersects match as closely as possible. So this is an intuitive way. Let's just go back to turn off. Yep. It's an intuitive way of making sure all of your intersects match as closely as possible, so when you go to create a depth grid, which you do within Geolitix as well, you have a nice smooth surface. So that's a pretty neat and very important functionality as well. So let's put our slices back on, and now and our GPR profiles. So here we are again. We've got our one pipe, but boy, there's so many other pipes we can see on these slices. Let's go back up to where they're really interesting. So something like this. Okay, so let's say I want to actually draw a pipe on my slice. Well, we can do that. We can go ahead and create a new polyline. So, sorry, right here. And you don't have to change the name, but we'll go slice pipe. All right, and I don't know, we'll choose, well, not green, because I already have green on the screen. Okay, and now what I'll be able to do is go click, 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 and follow it along. But let's just say that the slice, well, the pipe dipped down. It went down 10 centimeters. So as I go along, let's consider it going down some more. It doesn't, but let's pretend it does. I am drawing on that slice. So when we look at it in the side profile, now you can't really see it without a bit more exaggeration, but it does follow the slice. So that's another way of showing or drawing in utilities or pipes. So this is a very, very powerful platform that allows us now to integrate all different data sets into one place. I think I've basically covered everything I wanted to cover. I have my little notes here. Of course, within this World tab, we can do everything else. If I had done more interpretation of my pavement thickness, I could create a depth grid and some sort of isopac map from that. If I was automatically detecting rebar using artificial intelligence, which is of course already built in to Geolitix, then I can create an amplitude map within this screen here and show my corrosion or degrees of corrosion as well. So again, single channel, multi-channel, it's all contained within this one platform. As well as bridge DEG analysis, everything that you'd need to do with your GPR data set. Now, we won't go into all the different export functions, but I will show you that we can export as a Dxf file or as a KMZ, and literally just it comes up with a little box here, exporting files, it's zipping everything up, and it outputs it as a KMZ file, which we can then go into Google Earth. It'll download automatically into your downloads directory. You can then go into Google Earth, click on it, and you can slice through all the different slices. You'll see polylines, you'll see your points, you'll see where your profiles are. Really everything you see within this 3D environment will be completely contained within the KMZ file. So that's what I wanted to reveal to you today, our new World tab and the increased functionality and the simplicity of the new workflow.